All right. You don't have any announcements or anything that you have to handle? Okay. Well, we can get started. So hopefully you all know we're talking about Data Vault. This really cool picture is what's on the cover of the Data Vault book. I've never fully understood it. I think it's Data Vault is fast, and the guy who created it likes cars. So that is Data Vault 2.0. So my name is Ashley. I know that some of you, sorry, there's a camera here, so I won't move. Okay. I think some of you have been in some of my presentations before. I've been presenting for about 2 years, really just because one time Rob, who is my boss, told me I should. And then Brigitte asked me if I would present, and I just said yes. So now here I just continue coming up with new things. So I presented on SSIS and SSRS. This one that I put together on Data Vault with a colleague, we put it together after taking the Data Vault 2.0 certified practitioner course. So we went through a 4-day intensive training on Data Vault. And so we were both able to go through that. And then we kind of put this together as a way to educate people internally with Baker Tilly, the company we work for. And then now I can speak about it to others. So I've been working in the data field for about 7 years. I graduated with a degree in education, so nothing at all related to data, but I kind of found my way into this field and I really enjoy it. So I really, I went to UW-Madison, spent a lot of time and money there, and then I built my career on YouTube and reading books and online tutorials. And so I've primarily focused on data engineering and data analysis. I've worked as a consultant first with Televant and now Baker Tilly. And then I actually just switched to an internal role. So I'm no longer consulting, but doing all of the same work, just doing it internally to help improve some of our processes and take what we do for clients and do that for us. So today we're going to be talking about, like I said, Data Vault 2.0. So what is Data Vault? Gonna do an overview of that, the methodology, architecture, the model. And then within the model, there are really 3 main entities. If you know anything about Data Vault, you've heard of hubs, links, and satellites. So we're gonna go through what each of those are, talk about some of the advantages of this modeling technique, some of the potential disadvantages, and then how you would identify if a company or client or anyone is a good candidate for a Data Vault model. Some things that we won't have time for just because this is an hour presentation. We're not going to talk really in depth about load patterns and ETL processes. So from a really high level, I'll kind of go through, this is the data that you would actually load, but we're not actually going to dive into how you'd set up those processes. Some of the advanced Data Vault modeling techniques. So we'll talk about the main structures, which I'll go through and it'll make more sense of hubs, links, and satellites. And I'll just kind of mention some of the other entities that you can have in your model, but we're not going to dive really in depth into those. And then again, because this is an hour, we're not going to do any type of a hands-on lab or anything today. And if you guys have questions as I go, please feel free to ask them. I will try my best to answer them. If not, I might call on Rob and make him answer them because he's the one who got me into Data Vault in the first place. So as an overview, if you've heard of Data Vault before, I think a lot of people have heard of, Kimball and Inman methodology. Data Vault is kind of, a third option, but it still encompasses parts of that. And we'll see here that when we think of that, the Kimball methodology and the standard star schema, that's still a part of the overall Data Vault approach. So you still need to be familiar with it. But there's kind of this distinction if you ever read anything or learn anything about Data Vault, there's a 1.0 and a 2.0. When we think of 1.0, it was the first iteration of this, and it really just focused on how you model the data. But this 2.0 version is really, he emphasizes it's a system of business intelligence. So it's a lot more than the model itself. It's how you go about building out everything to really start to derive insights from your data. So again, right there, it's not just the model, it is this entire system here. So when we look at Data Vault 2.0, and I'll just say Data Vault because otherwise it gets a little annoying, it is an architecture, a methodology, and a model. So when I'm talking about first the methodology, it's kind of this outer ring here. So a big thing that is really emphasized with Data Vault is that it integrates really well with an agile methodology. When you are working on building out your Data Vault, it should be an iterative process. So it should follow like a software development life cycle. You are constantly iterating and building and designing and testing and adding on. So that's kind of the methodology here. Then we talk about the architecture, which is really how you're going to set up going all the way from your source system to your end information marts, where you have your BI tools and your users consuming the data. So the standard data vault approach is kind of shown here, where we're going from a data source. We're bringing all of our data sources in their raw form into a staging area, which is our persistent stage environment. From there, we're bringing it into our data warehouse, which is what's modeled as the data vault. And then we're surfacing it in these information marts so that our tools can consume them. So the part that we're going to focus on the most, that is going to be really new and different from other methods, is the actual model. And when we start to dive into the model, that's when we can see we have all of these advantages listed here, that a data vault is scalable, repeatable, auditable, adaptable. You can optimize your loading patterns, and it's platform agnostic. Once we understand how the model works, then you can see where all those benefits come in. So diving into the model. This is, and you can't see my mouse here, if we are looking at just a data vault model, and this might look familiar because I've taken it from other presentations, this is what a model would look like. And the overall structure might look a little similar to what we would be used to seeing with a star schema. So the whole idea with a star schema, we have our facts and our dimensions, and we're defining relationships between them. A data vault does the exact same thing, it just has different types of structures. So here we can see hubs, links, and satellites, and it might be a little hard to read what's actually on each of these. So first we have our hubs. So you can see them there, they're highlighted in red. And I'll dive into each of these structures and what they actually contain. The hubs here are really our business keys. So these are the main things within the business that we're talking about. So products, invoices, salesperson, those are going to be in our hubs. The next thing that we have is our links. Links define relationships between the hubs, and their granularity is going to be dependent on how many hubs they actually connect. So links are what join hubs together. And then the last thing that we have are our satellites, and that's what provide context to our hubs and our links. So if we're thinking in terms of what we're used to maybe with a star schema, our links are most closely related to our facts, and then the hubs and the satellites that provide the context are really kind of what get us to our dimensions. So when we're diving into the entities a little bit more, the first one that we're going to go through is the hubs. So again, if we take a look, our hubs are here in red, and they are our business keys. When we're talking about a business key, we're talking about those items, like I said before, like an invoice or a product. So a hub is a table that is just a collection of a list of those keys. And it's however a user might identify something. So if we have, an item number or a product number, that's what is going to be our business key. It should be unique. And they should all be at the same level of granularity within an individual hub. And they can be composite keys. So if you have to, combine a few fields together in order to get your uniquely identifiable business key, then you can absolutely do that. And when we're working with hubs, we have a few standard columns here. So the first one would be our hash key. And when we're working with Data Vault, hash values are a really fundamental component to understanding the Data Vault model. So we have hash values in all of our main entities. When it comes to our hubs, links, and satellites, we have hash keys to help identify, to serve as a primary key for the table, so it will identify our records. So in order to get that hash key, we use a function to generate the hash value. And for this one in particular, for any hubs, your hash key is generated based on your business key and your record source. So I'll get down to this. Within a hub, we will have a list of all of our business keys, and then we'll have the source that they came from. So your record source would maybe be like your source system, some abbreviation of that, however you want to identify it. But when you're generating your hash key, it would be the concatenation of those two values. So you'd have your source and your business key, and that's how you generate your hash key. Yes?
I have a question. I'm assuming this is on. So I know I've worked with hash keys a little bit, and some databases seem to handle hash keys pretty well, and some seem not to handle them very well, where like joins across tables in certain databases can be really slow. Does that mean that, or joins across tables that are joined based on a hash key for the primary key tend to perform slowly? Does that mean that Data Vault is only really suitable for databases that handle hash keys well? Or have you had similar experiences? Or
I might defer to Rob on this one because I haven't had any performance issues with them. I mean, one of the advantages that's kind of listed is that you can have better performance with using those hash values. Have you seen any?
So,
Can you turn your mic on, Rob? Sorry. You had to know I was going to call you out too.
so on the performance side, generally the rule of thumb behind Data Vault is getting data into the warehouse, right? I mean, Data Vault is the concept of a data warehouse as a real warehouse. You store everything in a warehouse, not just your finished goods, right? If you think of like a manufacturer. So, to answer the question, yes, you will certainly see some level of performance degradation of joining a hash value versus an integer. And some of that comes back to how you actually store, the indexes in the tables as well, right? So in this specific example, you have to be careful because if you create the hash key as a clustered index, which determines how the physical data is stored on disk, you're going to end up doing a lot of reshuffling and there's going to be a lot of database operations. So it needs to be identified as a primary key, but not a clustered index. And you can index it, but I guess I don't know specifically what database platform you're talking about.
that performs poorly.
Yeah.
I was thinking of SQL Server.
Oh, I would be interested to see it. So again, I'm sure there is, if we get down to it, like, yes, an integer is going to be smaller than a hash. The data coming out though, right, is going to eventually end up in a star schema. The star schema can be used with surrogate keys like integers. The whole ETL process out, generally when we approach it first time, is let's create a virtual mart, right? So that you have
Spoilers, Rob.
All right, I'm done.
No,
See, I haven't seen the presentation, so
So essentially what you're saying is because there's this intermediate layer that's optimized for read or write.
yeah, this is optimized for getting data in and organizing.
So your next layer, which is not write optimized but read optimized, may not use the hash keys.
May not, right? Yeah, I mean, you could think of it as your standard, ETL process, like going into a star schema, right? And use integer-based surrogate keys.
Thanks. So yeah, I've worked with Data Vault plenty. Rob has worked with it a lot more. So I knew that I would punt a few questions his way. So yeah, continuing on, then some of the main fields that hash values. So thank you for that question. Like I said, that is generated from the concatenation of the record source and the business key. Then we're also going to track the load date and time, and then an optional field that you can have is a last seen date. So one of the things with Data Vault is that you, like here with the hub, like we're never going to delete data. We keep all of our data. So we want that last seen date so that we can track if all of a sudden a record has dropped off. We might set like a business rule to say, like, if we haven't seen this business key in this amount of time, we can consider that a deleted record. So hubs are pretty small in terms of the number of columns that we have. And those are the pretty standard columns. They can be called different things. I will emphasize, just because when you take the course, it's really heavily emphasized. A lot of this is the way that like I have worked with implementing a data vault and what I found really works best. But definitely for if you want like the by the book best practice approach, then I can show you the giant book I'm carrying around. That's the Data Vault book. That's a really good resource. So we're talking about hubs. At a high level, the loading pattern that we want to work with here is we'll bring in our source data. We'll say, does this item exist, this business key? If it already exists in our data vault, we don't do anything. If it doesn't, then we land the data. So that's going to be a pretty common pattern. Moving on then, from hubs, we have our links. So if we look back at our model, our links are going to be in blue here, the thing that really join all of our hubs together. As I said before, they show the relationship between our hubs. So if we're thinking of like an invoice, for example, all the different things in an invoice, we might have our customer and our item and all of that. Each of those are going to be represented within the hub. So here, the hash key is really a composite of all of the hash keys from all of the hubs that it joins. So when I'm looking at the bottom of this table here, if this, in the example that we show here, we're joining invoice, product, salesperson, and customer. If I look back at this table, then each of those hash keys would be represented, and then the link hash key would be a hash generated on all of those business keys. And then again, we're going to have the load date time and then the record source of where we're actually pulling these from. When we think about links, we're not showing effectivity here. So we're not showing like when a link was actually effective. If that's something that matters for the relationship that we're showing, then we have other options where we can add satellites, which I'll get to, that the satellite can help show the effectivity of a relationship if the relationship can change. But otherwise, we want to show the time when we inserted this record, but we're not ever going to be updating anything. So the standard link shows those relationships, and the granularity of it is dependent on how many hubs you're joining. So the more hubs you join, the more granular it's going to be. In addition to just the standard link that shows those relationships, there are some other types of links that you can work with. So we have a same as link, and that would be, say you have a situation where you're bringing a bunch of different source systems together and you have customers that repeat in those different systems. You can set up a link that essentially, will tie two customers together, and then it will allow you to say, oh, if you ever see this customer from system B on the reporting side, we always want to see it as it is in system A. So we have a link that will help you with that. And then kind of in a similar vein, we have a hierarchical link that you can choose to implement, and that does the same thing. It'll show a hierarchy in that same way. So those types of links would be joined to a single hub. So they wouldn't join a bunch of hubs together. It would just be a single hub with that link that essentially kind of joins back to itself. And then there are also things like a non-historized link, which I won't go into as much, but that is just a transactional link. So anytime you want to show relationships or transactions, we want to look at links, and there is some flexibility with the different types of links that you can work with. And the load pattern for a link is going to be the exact same as a hub. So we're going to pull in our source data. We're going to say, does this link already exist? If it does, we're going to ignore it. And if it doesn't, we're going to land it. So we're going to create that link. And then the last entity that we have is our satellites. So when we look at our model, again, our satellites are here in green. And one thing I want to point out, so this model that I have as the example here, this was for a demo that we did internally, and we were working with two different source systems, AdventureWorks and Worldwide Importers. So if you see our satellites there are two satellites connected to every other entity. So we have hub satellites and we have link satellites. A satellite can be attached to a hub or a link, but it cannot be attached to another satellite. And a hub or a link can have multiple satellites. And when we're looking back at this, so going back to that, you see appended at the end, we have our different source systems. So we want to have a satellite per source system. And this is where a lot of our flexibility comes in. Say, from one source system, we might have 20 columns worth of information on our customer, where in another source system, we might only have 5. We don't have to try and make those conform to each other, because we can bring them all into their own satellite, so we won't have to change those structures around. And then when we get further down the line where we're putting this into a star schema, that's where we can try to conform some of that. So within the satellite, like I said, one per source system. This is where we're storing all of our context. So we looked at our hubs and our links, and they were pretty small in terms of the number of columns we're working with. Here, a satellite, there's no limitation. So any contextual data that you want to store, as long as it's all at the same grain, there's really not a limit on the number of columns that you would want to have, other than system limitations depending on what you're working with. Yep.
just a question about the one per source system.
Yep.
In a situation where, for Nordic, let's say we were to acquire a company that uses a source system, the same source of system as us, but let's say one is more customized than the other. Would you have a satellite for each version of the source system, or would you conform the source system to itself?
I would have a separate satellite. Sorry, I felt like you moved. I would have a separate satellite for that because the information would be different. I think it would also depend on if you're still using both systems actively. Because if that was the case and like one had certain information, one had different information, then I think you'd want to have separate satellites for those so that they can both keep ingesting that data.
Well, did answer your question. I don't know. So it sounds like it may be fairly common that satellites and hubs have the same grain, where you'd have a one-to-one relationship. Is that true, or they usually have different grains?
So you would want them to be at the same grain. So if you had like an invoice hub, an invoice hub that was an invoice header, and you had a satellite attached to that, then that would be at like the invoice header level. And then if you had a different one or like a link that was an invoice line item, then you'd have a satellite for that. So they should be at that same level.
Oh, so they're always at the same level. The hubs and the satellites are always at the same grain.
Yes. Yeah.
Okay.
All right. So our satellites, like I said, it's like contextual data. So when we're thinking of them kind of in terms of our star schema, it's very similar to what we would think of for our dimensions. Especially if we're thinking about like a slowly changing dimension. This is the one scenario here, because it's kind of the most flexible construct that we're working with, where we would actually, put in an end date if something in our relationship changed. So the way that we work with satellites, and we can see the fields here, again, we have the hash key. So this hash key we generate as we're populating the satellite itself. So we're not doing a lookup on the hub to get the hash key, but the hash key would be the same value because it's at like that same level of granularity. So that hash key that's in the satellite is how we would join back to our hub. And again, we're gonna determine what that is. We're gonna run that function at runtime. So there's not that dependency there between the two. We're gonna put in the load date, the end date if it's applicable, if that's something about the satellite has changed or the element within the satellite. Again, the record source. And then the one that we have here is we have what I have called like our hash diff. It's really just the hash value of the entire row. So we want to figure out or compute the hash values for all of the values within that row so that we can more quickly identify if there has been a change in the record. So that's the way that we're doing our change tracking or determining if there's been a change. And then again, the extract date, just to figure out when that data was actually taken from the source system. So the load pattern here for a satellite is a little bit different than the others in that we're going to check to see, we're going to pull from the source. We're going to say, does that record exist in the state that it's in? If the hash key value actually exists, but there's been some change that we detect in the record, we're going to expire the old record, so we're going to put that end date in there, and then we're going to land the new record. So it's very similar to if you're thinking of a slowly changing dimension. It's going to function in that same way. And then moving on from those entities, I was just going to say, unless there's any other questions.
The one thing I'd be curious about there is in like a master data management scenario where, let's say you have two satellites for customers from different systems, and you have the same customer in both systems, how would you handle a scenario where you're trying to end with a golden record?
So that goes back to kind of talking about the same as link. So if I go back to the model, this one will get me there.
Okay.
Oh, go ahead.
Technically, you're supposed to have matching business keys, right? Isn't that the rule? Your business key matches in both systems. Doesn't that always happen? Yeah, just kidding.
I also thought you were serious. I was like, where do you work?
No, that never happens. So yes, the same as link is the right approach. So I'll let you go now.
Yeah, so the same as link, like we had talked about, so you would have that, like, I'll just walk over here. So same as link, you would have just coming off of one hub. And if you had, so your hubs will have records from all of your source systems. So your same as link would attach to that and would have the multiple columns, say like column A, this is what our master record is. And then column B, like this is what the customer's called in the other system. But then when you get to that virtualized layer, that's where you can put in that logic to say, if you ever see this customer, we want the data that's actually coming from this source system. Does that make sense? Okay.
Would the expired record in the satellite and the replacement record, the new record,
Yep.
have the same hash key?
Yes.
So they do have the same hash key. Okay. So doesn't that mean that then that the hub would have, so then would the hub also have an expired record? So the hub, so then they have a different grain, don't they? Because you have expired versions of.
So think of it like third normal form where you've got an entity, right? You've got a business key and all of the context around that, right? Same concept. The satellite always has can only have one current record tied to that hub or tied to that link, right? I mean, the rest of the grain just shows what that data looked like at a certain point in time. So it's still the grain. It's just saying that this customer looked like this today, but yesterday it looked like this. And 3 weeks ago, it looked like this. So it's still technically the same grain as the key, but yes, you will end up with multiple records.
Gotcha. So there's more records in the satellite than there are in the hub.
Yeah, absolutely.
Of history.
Yep. And with the satellites, as Ashley mentioned, one of the, that's where you get the flexibility and that change, the volume of change is certainly something. Am I talking about something you're going to talk about in 2 seconds?
No, you're good.
Okay.
You're good.
So the volume of change is something that you want to keep in mind, right? If you've got say you've got a satellite with 40 columns and you've got one column that changes every day or every 5 minutes, that means you're going to expire and insert the same data every single time. So you might as well take that and break it into 2 satellites, because you've got one that's going to rapidly change and the other one where it's very static data that will remain consistent for a year or whatever that looks like, right? So there's a lot of different paths you can go for customizing how the satellites are loading all of the extra context around your hubs.
Gotcha. One other question. So like if you imagine if you had a person record and some of the information about people is pulled out of census data, and the census data you're pulling is at the zip code level. So in your hub, you'd have a row for each person, and then you'd have a satellite because the census data is a data source that's at the zip code level. And because you want the grain to have the same, that means that your satellite from zip code we would just have a lot of duplicates. Everybody from the same zip code would have all the same data. I mean, you realize you can make a data modeling choice where you split that out into a different hub, but.
No, I'm trying to follow. I'm trying to follow. So you're saying like if the satellite was only.
Yeah, the information was at the level of zip code because it's being pulled from the census, but it's associated with each person, right? Because each person has zip code.
Or, I mean, you could store that if it does really pertain to every single person in that zip code. You could attach that to that person record.
Right, but you would duplicate it in your satellite because your grain is supposed to be the same. Your grain has to be at the person
what
level.
Satellite? The person satellite?
Well, so I'm thinking the hub is the person hub.
Yep.
And then you have a satellite for each data source. One of your data sources is census.
Okay. Well, then, so at that point, you'd have so you can't have a census hub tied to, like, you can't have census tied to an exact individual. I mean,
yeah, it's tied by zip code.
Right, but that would be tied through a link of some sort, or it's going to be joined. I mean, you wouldn't end up with duplicate. You would not end up with duplicate records based on the census data.
You would create a different hub for that.
Yes. Yeah. I mean, your census data is not a person, right?
No, it's not. It's
so
not
it
by,
would be as its own.
right. So if you have a source that's not naturally at the same grain as your hub, you create another hub for that.
Correct.
Okay.
Yep. So hubs are like you can think of them as your objects, right? You've got, I mean, your census data might be a little different because it could be a different variety of things, but overall, that would be a separate entity altogether.
Right. Because like in Kimball, sometimes you might choose to put census data in the person dimension, depending on how many columns there are, or you might choose to make it its own dimension. It would sort of be a choice, right?
Right.
Yeah.
Same concept here.
Yeah.
Yep.
But if you chose to associate it with the person, then you would have lots of duplicates in your census data satellite.
We'd have to draw it out.
Yeah. All right.
Okay.
Anyway, sorry.
I was going to say we can. So I think I was in this very unique position in that I learned Data Vault before I learned Kimball, which I don't think happens to anyone. But I think it was a lot easier for me to understand just because I learned that first, and then as part of it, good segue, not even intentional, I started to learn like star schema. So that's what we're going to get to now, and this is what I yelled at Rob for spoiling earlier. That even though we have this data vault model that, as you're learning, can be, so we're focusing on just the main entities today, but like it can get a little confusing quickly if you're not super familiar with it. So there's a lot of design decisions that go into like how do we know what to put in a hub or satellite, or having those conversations. So then now we want to think about how do we get from like all of that into a way that we can present the data for users. So the way that that's done with Data Vault model is with information marts. So there's this really heavy emphasis on information marts, not data marts, because we don't just want raw data. Information is what we can gain insights from. So they make a very distinct mention that we are working with information marts. And this is what I think a lot of us are really used to seeing is this star schema. And this is kind of what was mentioned earlier, that even though we have a data vault, we're then taking everything from that and we're putting logic over it to put it into a star schema so that it can then be consumed. The standard idea here, one of the big reasons it's done in this way is because we want to be able to separate our hard rules from our soft rules. So that means when we're bringing our data in, if there's anything that we have to do to like clean the data, that's going to be like our hard rules, like making sure data types are correct. If we have soft rules, like our business rules, like we're aggregating data, we're calculating different things, where maybe we want to see a name, shown in a certain way, pulling from the first name and last name. That's what we're going to do in these information marts. So the idea here is they should be virtualized. So we should have them in views for as long as you can until performance might dictate otherwise. So the idea here is that first they should be in views. If from there you're having performance issues, then you could go to materialized view, and then you could go to actually persisting it in a table. But by keeping it in a view that allows the model to be really flexible, if this has probably happened to everybody if you've ever worked on something like this, down the road, all of a sudden with a dimension, someone wants to like add a column or change the way something's being calculated. If you have everything virtualized like this, it's really easy to make those updates and have it impact everything historic, as opposed to actually going in and making an update to the way a table is being calculated and going back and having to deal with all the historic data. So virtualizing it in that way makes it so you can be really agile with those updates, and then that layer is what is actually going to be consumed by business users and BI tools. So, if you have like a Power BI dashboard or something hooked up, you would be reading from those views. So going through all of those entities and the way that the data is structured for consumption, that's kind of what leads us back to those advantages that were listed out at the very beginning. So the first one here, Data Vault is known for being really like scalable. So we talked about how our satellites, we have satellites per source system. So having it broken up in that way allows companies to scale quickly, say like through an acquisition. All of a sudden you bring in a new company, you have all of these new systems, the data doesn't align one-to-one with what you might have. It doesn't have to. So you can pull in a satellite, and then when you virtualize it in the information mart layer, that's where you can pull different fields from your different satellites and try to kind of conform things that way. So it allows you to scale really quickly. Just keeping in mind, like if you do add those new source systems, then you're going to have to make updates to the views that are in the information marts. The next huge advantage is that it's very repeatable. So I think you could see from especially the hubs and the links, those columns are going to be the same. So if you have a good, if you have your metadata set up correctly and you are, thought I hit something there, you can create scripts to automate tasks. There are a number of services that you can use that are, they work with Data Vault that really, if you have your metadata set up in a way to identify, okay, this is the business key that we want to be using, you can really quickly generate all of the objects that you need as long as you model it out correctly. So having it repeatable in that way makes development really quick once you start moving. Auditable. So one of the core principles with Data Vault is that you don't ever delete anything. So you have an entire history of your data. And that's become really, really important with a lot of new compliance regulations to be able to audit your data quickly. So if any of you have to work with things like GDPR or other data protection regulations that are becoming a lot more common, they give people the ability to say, hey, I want you to remove all of my data. So having the business keys set up in the way they are within the Data Vault, it makes it easier to track where, say, a person, where their information is throughout your Data Vault. So being auditable in that way can really assist with some of those.
Does that mean that you never use type 1 style slowly changing dimensions? Like you never overwrite data? You always
Correct.
use type 3?
Yep.
Okay.
Adaptable. So this is what I was talking about before, where we have our, we separate our hard and our soft business rules. So like I said, a hard business rule would be, it's not changing the content and it's not changing the grain. So it would be just making sure like data types are correct and that sort of thing. Our soft rules, we push as far down the line as possible so that if there are ever any changes requested to those, we can make those changes quickly. And then that just kind of goes back into the idea that the Data Vault is really aligns well with an agile approach when you're working on development tasks. So changes in business logic are really easy. I mean, I say easy, there's still work there, but they're a lot easier to implement than with a traditional model. Optimized loading. So we really decrease the complexity here with actually, getting our data loaded. So we're only, once our data is in our persisted stage environment, we're really only pulling things into the Data Vault if there has actually been a change. And because we've limited the dependencies between a lot of these structures, so I said before, with our hash keys, even though they're the same, between our hub and our satellite, and that's how we join them, we're not doing a lookup on the hub to get the hash value for the satellite. We're always going to be actually calculating that logic because the hash function is deterministic. If you put in the same input, you will always get the same output. So by separating those out, you can kind of stagger. You can stagger your load patterns, and as soon as you get a source available, you can maybe start to load that source, and then your next one's available, you can load that source because they're hitting different satellites. It's not always necessary to do this, but there is a lot more flexibility with your load patterns. And then another one here, platform agnostic. So if Brigitte loves working with AWS, he can work with AWS to build out his Data Vault. I've really only worked with it within a SQL Server environment. I know that there's been a lot of work done within Snowflake, a lot of companies who are implementing Data Vaults there. I don't know if anybody here has experience with a Data Vault in any other environments, but really it's not platform dependent at all. And then a couple of the disadvantages really is, one, it's not a super well-known technique. So if a company wants to work with a Data Vault, they have to either hire for that skill or they have to be willing to train people. I think it's really interesting. most people I know don't think it's super interesting, but I don't hang out with a lot of people who love data as much as all of us do. But you have to really be able to like find people who want to learn this technique. And I think once you start working with it, it is really exciting to work with and to see all the different ways you can model data. And then also, as we've kind of talked about, until you really get comfortable with it, if you look at an actual data vault model, they have a tendency to become really big really quickly. And that's not a bad thing as long as you understand how it's working. So it can just be a little bit overwhelming. But once you start to understand how it all works and the advantages of that complex model, then I think you can really see why it's advantageous, but there's just kind of that learning curve right in the beginning. So bringing all that together, like who would be the best candidate for a data vault? It's not necessarily the right approach for everyone, but some of the big things to look for would be if there's a desire to integrate multiple source systems. So if there's a company that's growing really rapidly, either organically or they're acquiring a lot of other companies and bringing in new source systems, then they might be a good candidate for Data Vault because you have the ability to do that. Or if they're just switching systems that they're working with. So if they're looking to scale in that way. If they have a really, heavy emphasis on an agile approach to development, then they really go hand in hand, like I've tried to talk about, and that's emphasized a lot when you're learning about Data Vault. And then really, if they have, like I mentioned before, if they have the staffing or the ability to hire staffing to support maintaining a data vault, that's really a big thing as well. Any other questions? No, we wrapped a little early there. I think we got started.
I have a question about the statement you made about it being more very well suited to an agile process. Mm-hmm. So when I think of like things that make agile processes easier or harder, I think of an agile process being easier when, like in the metaphor of the cake, when your cake has not that many layers, mm-hmm. right? So when you add layers to the cake, if you're trying to deliver your solution in an agile environment, then each slice has to have more layers in it. Mm-hmm. And so each time you want to make a small change, you have to make it to more layers, which I guess in my experience makes delivering those slices, right, those agile iterations, harder when there's more slices. And compared to Kimball, there's a couple of different additional layers in this process, right? There's the additional layer to your data model, right, of the 3 different types of tables instead of 2. And then there's your information marts, whereas in a Kimball model, you may not have that layer, mm-hmm. right? You often just surface the whole model. So am I thinking of that in the wrong way, or is there something that sort of counteracts that need for additional layers that makes it better, more suitable to Agile than a Kimball?
So if you're thinking about, say we want to bring in like a new source system, so I think that lends itself to an Agile approach. You might already have, like your hubs might already exist, your links might already exist, and really you're just bringing in that contextual data. So that's where we just have to add a few satellites. And you could be really quick. So when it comes to, we've really pulled the dependencies away from a lot of these structures. So you could add on a couple satellites quickly and really quickly deliver that and say, okay, we already have this data in there. And they don't have dependencies on anything else. So you can do that quickly. Another thing is you can kind of take a few different approaches. Say you are starting your model, you kind of have it figured out, and you just want to start with one source system to be able to quickly deliver, here's all that data. Okay, and then you can go back and you can build another source system around it, and you don't have to re-architect anything. So as long as you might already be pulling that data into your stage environment, it's building those additional entities. But if you're using a pattern-based approach, so if you've come up with scripts that will generate the objects quickly, bringing it into the data vault itself is not going to take that long, as long as you can say, here's our business key, that's what we're going to generate our hash key off of. All of your objects will be built quickly. So you can kind of take that approach of, we're going to focus on this one source system and we're going to build that out. Or you can say, the business really only wants to know, they really want to see something quickly on this business process. So you say, all right, we'll start with building out that link and the hubs and the satellites associated with it. But then, okay, we're going to bring in this other process, and you can see where that fits. But you don't have to make changes to the things that you've already built. Does that answer your question, or?
I think kind of, yeah. And it sounds like a lot of that is enabled by the use of hashed keys.
Yeah, the reduction in the
The
dependency.
reduction in dependencies that you have to redo when you bring in new things.
Yep.
Okay. Which you could use hashed keys without using Data Vault, right? It's not, you don't have to use Data Vault. To use
Right.
hashed
Yeah. I mean, I think it's a pretty common thing, especially if you're doing like change detection between rows. I know we do it a lot to, you don't want to compare 200 columns. If you hash those values, you can easily compare those rows. Yeah.
Okay. Thanks.
Yeah. Yeah.
In terms of the virtualized layer toward the end of the process, especially in a scenario where there might be a lot of derived data that might not live in the source systems and you kind of come up with it as you go.
Yep.
How would you handle a slowly changing dimension approach for the information marts as well, if they're only in a view layer? Like, you would almost have to implement a table, wouldn't you?
What do you mean by derived data?
Yeah, so if we could say, let's say the concept of a territory doesn't exist in our source system, and so we have to create that based off of the state. Right. If that doesn't exist in our source system, then we have to derive that data somehow, and that doesn't show up until our soft business rules in the end. How would you track changes in that if we make changes to our soft rules?
So there's kind of a couple different approaches. Do you think this would fit into like business vault? Okay. So I didn't dive into this just because I didn't want to get too complicated with it. But in addition to the data vault, there's this idea of the business vault, which is, it's still kind of within the data vault. But if you have like business logic that you repeat over and over, maybe it's like an aggregation that you're doing a lot or something like the example you just gave. There are additional tables. So this is where it gets into the advanced data vault modeling. There are other structures where you can store that kind of information so that you're not constantly having to like compute that, or so that you can track that history. So that's where we would get into, and it's called the business vault because it's more of that business logic that you're calculating. But if it's something that you're using over and over, you can put it into the business vault, which is, like another schema. And that's where you can do a lot of that logic. And I haven't worked as much with some of those advanced modeling techniques and those tables that you can use for that, but it is an option to take that away from that virtualized layer so you're not constantly having to recalculate that, and you can track those changes. Is there anything you can add? Because you're...
Yeah, I was just gonna say the way I would approach it would create a new satellite that lives in that business layer. And like Ashley said, it back to Jeremiah's point of his cake, right? Like, this isn't really a new layer. It's just a segregation by schema within the database to say, this is very clearly where business logic happens. Everything else where we have raw data is called the raw vault, right? So in that exact scenario, there would probably be, whether it's a code in a proc or table or data in a table to join in. And if you want to track what that looks like over time, the approach I would take would be to create a new satellite in that business schema so that that business logic was applied to it, but then you can still write that data and have the effectivity if something is changing territory because we reorganized, Nebraska into, for some whatever reason, the eastern region, then when did it change, and that can flow through into your type 2 or type 7 star schema dimensions.
Yeah, I had the business vault in here and I kind of took it out because it can get confusing that it sounds like it's another step in the process, but like it's a schema. Like, so it's part of the data vault, but just thought of in a different way. And so I pulled out this book. So like I said, the modeling can get complex, and this is a good read. I recommend it if you're interested in data vault. But it's definitely, there are so many different scenarios and different types of links and satellites that you can kind of bring in to handle a lot of that. Any other questions? Oh yeah.
I would say one example, virtualized layer is the Kimball methodology, load a dimension. That dimension loaded and it's fixed, and the data is fixed. And changing it reload the entire scratch. Whereas with the virtualized method,
Mm.
it would be easy. All of the data is in the satellite something. So, and all of the history is in. So then you can change like the soft logic, the business logic, and start saying, well, no, I want to know who the time of the sale, not today. Make that change in the virtualized layer, changing anything else, not changing the data vault, and it's a very quick change, and the data starts flowing through whatever it is, Power BI report right away.
So like what you were describing of your scenario of you're at a company that keeps getting into different kinds of service offerings, which are offered at different granularities and stuff. I mean, it seems like it could be a good fit for that kind of a scenario.
One thing I would
Sorry. Yeah, the one thing I would be nervous about is just being able to track changes in that business logic. And obviously, if the business vault can handle that, that would be a helpful solution. But yeah, I definitely see the benefit to not having to change your ETL and all that.
Yeah, and that again, that goes all the way back to the agile approach of all of a sudden we had this request to change the business logic. You could do it a lot quicker. Because I've definitely worked on plenty of projects where all of a sudden they wanted to change something about a dimension, and so all right, let's change the 3 years of history that we have here, and it's a fun process.
I think one thing to add to Leonard's comment, he talked about a business process changing, right? And that happens a lot. And generally, when you look at a data vault, the link construct is tied as close as you can to your fact table. So one of the things that business processes change is the grain at which things are tracked, right? So getting back to the auditability and the fact that nothing's ever removed, if a business process changes or the grain changes, everything still remains in place for the prior grain. You'll be adding that next join, right, to a new link. And then once you have that new link, all of the context will still be there for the prior satellites, for the hubs that were tied. And I wish I could draw this out because it'd make a lot more sense. But I think getting back to Leonard's comments, it really does lend well to the extensibility of seeing how business processes can change and evolving your model over time while keeping, the history that you may need for any type of audit.
Can you give an example of a business process change and how that played out?
So actually, this is a good one. Say in this scenario, right, this was a fictitious company that purchased Wide World Importers and AdventureWorks and decided that they wanted to have visibility of sales across both organizations, right? In this scenario, maybe it didn't make sense that they each had sales lines, right? Maybe one just had invoice and there's no invoice lines. So generally, that would be the grain of something that is changing, right? You've got your high level invoice of $10,000, and then another company actually says this invoice for $10,000 is, $5,000 for product A and $5,000 for product B. In that scenario, you'd be able to still bring in both companies' data and be able to have the high level view of all invoices. And then, ultimately, since you only have the line item, pick one, right? AdventureWorks. Maybe they have line items. I don't know. That would be an example of a grain changing. Basically, you're able to add more context, or going back to your agile approach, right? So say the business says, hey, we want to be able to see all sales by customer and by product, right? Okay, you build your hubs, your satellites, and your link of customer and product, and then they come back and say, no, now we want to also add salesperson. So that would be a change to the grain, where then we would be able to add that additional link to the salesperson and have that context come in.
you went from the one line per invoice to multiple lines per invoice,
Yep.
right? The first company was one line. You bought a company that has multiple lines.
Yep.
You still have to change the cream on your link.
You can create a
No,
new
you would
link.
create a new link.
You create a
Yeah.
new link.
Yep.
And you would archive your old link.
You'd let it sit. I mean, there, it gives you the, you have the whole process of winding things down too. But, yeah, you can eventually wind it, or I'm sorry, you'd wind it down as far as maybe data being into it. But the whole concept of the auditability is that everything that's ever been reported can still be reproduced because it still exists today. And we aren't ever like truncating a fact table and reloading it today. It would just be, here's the current version of the data today.
That's probably part of the reason that you described your model's growing so fast. It's because you've changed your business process. You have to have.
And all changes a non-destructive way.
It's weird because he's so loud too.
So all changes are non-destructive. So you never break something if it's working. You only add new data, new links, new satellites, new hubs potentially. And then on the data mart level, in the soft layer level, that's where you might union in a new piece of logic or something like that. But you're not breaking anything that already exists. So you can load new data without ever breaking your data marts or models. You can check that data is golden in your data vault layer before you ever add it into your data mart and start pushing it out to end users.
Are there, like, it seems like whether you're going with Data Vault versus Kimball might have some impact on your choice of ETL tool. Like, I'm just thinking of a lot of the language and the use of hash keys and stuff is pretty common within the community that uses DBT as their, T tool or ETL tool or whatever. Have you had experiences that lead you to think that certain kinds of ETL tools work better for Data Vault versus Kimball?
I haven't had enough experience with different ETL tools. I don't know if you have, Rob, but when I've done it, what I've done before, I've really relied on like stored procedures, like within a SQL Server environment that is applying that hash logic. So I don't know.
So then you just use an orchestration tool that it wouldn't really matter which one it was.
If you got SQL Server, my favorite thing is you get rid of satellites altogether. And you just use temporal tables. You don't have any logic anymore. You're just updating it, handles all the expiring. And I know we've used that successfully several times. And it's pretty slick that the way temporal tables works, where it has the history table. I guess back to specifically your question, I guess there's maybe two things. If you have a large environment, even bringing all of this into like a star schema Kimball model, you're going to have to go through the same exercise, right? You have to bring the data in, you have to integrate the data, you have to determine business logic. Those things still happen in Data Vault. The difference from my point of view, the difference in the benefit is that there are very clear and concise ways, processes, and definitions around how that works, right? So we are always keeping raw data. We can always go back to what it was. Anything that is technically in the, the business layer is where business logic is applied, but it could always be reproduced back from that raw data. Specifically on the tools, I think all of the major ones that I know of, as I think through DBT, there's Warescape, there's Bimmel, there's a couple of them on the AWS stack. They generally like Data Vault because of the consistency and how the objects are defined. So it's easy to actually build those patterns out. And I don't know that there's really any difference because it's still moving data, joining data. It's the same database operations. So I don't think that there'd be a tool other than number one, how fast can you actually deliver with it? That'd be the question number one. And number two, how much flexibility do you have beyond hub link satellite, right? Can it do things like same as link? Can it do historical or hierarchical links? I mean, those would be some of the questions. And I've seen some that are really cool. You can go in and say, here's my satellite, and I know it's getting a lot of changes. So we're going to right click, choose split, and it splits up based on the columns you want. And now all of a sudden you've got two satellites, and it generates all the DDL, creates the new tables, reloads the new satellite with the current effective date. So there's a ton of features for sure.
And I would add, this isn't a replacement to Kimball. Like Kimball still sits on top. So this is more prepping the data so that Kimball, with Kimball, you're loading your dimensions and your facts, and you're doing the integrate and the business logic all in one giant massive query that goes against a bazillion normalized source system tables. This way, we're prepping the data so that there's like fixed numbers of satellites and business entities, and then Kimball is just pulling the data out of that. So it's changing that layer underneath Kimball rather than replacing Kimball. I would say the only thing that changes at the Kimball layer is the presence of those hash keys, which is not my favorite either.
That's a great point. Even as you read through the Kimball books, it talks through like, here's the front of the house and here's the back of the house, right? I mean, essentially you're pulling out the back of the house and replacing it with Data Vault. And honestly, anything in here is going to be way too complex for, your typical business user to try to figure out how to write a query against it, right? It is not meant for that. It is meant to store all your data, and you still need a presentation layer downstream.
I like the way you described like splitting out how it splits out the different queries into different situations, as opposed to one huge extract transform query, because then it makes your unit test definitions easier and your debugging easier because you can trace things back more quickly to where they occurred.
We do have an online question.
Is it?
Up to what size is this way? So in SQL Server, what database sizes have you done Data Vault stuff on, and if it's been on premise or cloud?
I'm going to go to Rob again for that one.
Database sizes. I don't know. Probably pushing a terabyte would be my guess. The thing about and to answer the question, on-prem or Azure, it doesn't really matter. I would say one more interesting topic is we talk about the hash keys. And I think the question reminded me of it. The whole, well, not maybe the whole, but an additional benefit of these hash keys is that when you use MD5 to generate the hash key of your business keys, you could end up in an environment where we'll use the example of an acquisition, right? Maybe there is two companies coming together and they both have rockstar BI teams. One of them does it in Snowflake and one of them does it in SQL Server. At the end of the day, your hash keys can, if you have a tool like Power BI or something that can consume data from different platforms, those hash keys can join across different systems, right? So I know somewhere in that book it describes even being able to do cross-platform like data storage. I know that was my thought too. Like, why the hell would you ever do that? But the example, yeah, but you can. I've, to be honest, never done it. Sounds like a fun exercise, but
Hired a new BI director who made it. New tool.
yeah, I actually have, there was a project once where there was a product dimension, and for whatever reason, we ended up using the existing product dimension in the data vault model, rather than going. And I can't exactly tell you why we did that, but I know that is another thing, right? I mean, as you have a dimension, your dimension has generally business keys on it. You can generate hash keys even from that. I don't know if that helped answer the question. Probably
Of database size?
a bit of a rant and rambling.
Didn't say anything, but yeah, I guess it didn't address the size thing.
Yeah, I mean, so I do. I mean, I know this is, for what it's worth, like this is one of the implementations the Department of Defense uses for all of their warehousing, right? And that's talked throughout the book. So I can only imagine that. Huh?
Those where it was developed.
Yeah.
Right?
So I
For the
can
Department of
only
Defense.
imagine the data volumes there. Again, kind of the core tenant is all data all the time, right? So you're definitely going to have the challenges of, I've got billions of rows of data, and how do I get that out into something else? This isn't going to solve that. You're still going to have those challenges, right? So partitioning and all of the other things you'll have to do.
And this, like, to Rob's point, this modeling technique, it's not as familiar here, but I think worldwide it's used a lot more heavily. I know, like, again, going along with the Department of Defense, I think like the largest railroad in Canada, railroad company, I don't know, they also have a data vault. I have to imagine they have a large volume of very important data that they're working with. So like, it's not as widely known here, but it's implemented worldwide all over the place. I think it's really big in Australia. I know that.
The 20 people that live there.
Yeah. Any other questions? Anything else online? I can't see there.
Could we see that slide with the presentation layer again?
Sure, if you tell me when to stop. Let's see. This one?
Okay, well, that will work, yeah. Well, going from the warehouse to the information marts, I'm just wondering, is that mainly done by SQL or other language, or?
Yeah, so this, I think the picture here is kind of deceiving where it looks like a process, but yeah, you would just have, like, if it was a view, you would just have like the SQL view sitting on top of that logic, sitting on top of that data vault there.
I see.
So you're not moving like from the data warehouse, like the data vault, to that information mart. You're not really moving data. You're just putting that logic on top of it.
You chose to transit. You would have process.
Does that answer your question?
Well, I'm still wondering if does it mainly use SQL, or is?
Yes. Yep.
Okay.
Yep.
Okay. Yes. I understand.
All right. Well, I think that concludes. Do you have any other announcements?
Hello, can you hear me?
Hello?
Yeah, this is Jesus.
Hey, did you have a question?
Yes, I have a question probably. We can distinguish during the ETL some time for the data ingestion, and then we will produce reports via BI or some other tool. So when the data vault grows in terms of 2, 4, 6, 8 terabytes, there are noticeable times between the ingestion and the report generation.
Oh, sorry, asking if there's like a noticeable lag.
Yes.
I don't think I've worked with that volume of data going into a BI tool. I don't know. I keep looking at Rob, but anybody else who, if anybody else has relevant experience.
So when you talk about ingestion, I mean,
Yes.
you're not re-ingesting all of that data, right? I mean, you got some kind of incremental load to handle smaller data coming in, right?
Well, the thing is that I have seen one implementation of Data Vault in the past. I am not sure if they didn't apply the correct model,
Okay.
but any incremental load was loading the hubs and the satellites again. So if we had 100 million rows in the first month, in the next month, we will have 130 million because 30 million came additionally. But that did not happen at the end. We have something like the fact tables, and they will be 230 million. So the increment plus the initial. I don't know if that was just a bad approach in the development, but at the end, what I had to do to attack the performance problem was to not rely on the views, but to come with physical tables, column star index, and bring that up because it was slow.
Yeah, for sure. I mean, your virtualized information mart, I'll use the right word. Your virtualized information mart is not going to perform like a persisted table. And when you start getting into large data volumes, your star schema will need to be persisted so that you can still have the indexing and the performance like you would out of a typical star schema. To your question about going from what should be 130 billion to 230 billion. I mean, I guess I'd be looking to see if when you look at the two records that are now duplicated, have they in fact actually changed? And if they have, then it's complete valid data. And the query just needs to look at the one with the current effectivity date, and the other one would be the history. But if they are both in fact the same, then I would say there's probably something on the ingestion side that isn't doing the comparison, whether it's a row hash comparison or using something like change tracking or CDC or some other process to do an incremental load into your satellite. There should never be duplicates in your hub, though. That would be a major problem.
Okay. Yeah, the duplicates, there are no duplicates. The thing is that we never had, like from the Kimball approach, that we had the change one, and here is never possible. So yeah, okay, thank you.
Yeah, and then just to highlight, going back to exactly what Rob said, that, yeah, if you have like a ton of data you're working with where you're having performance issues from a view, then you absolutely want to persist that. Or if you have the option to put it into a materialized view so that it's still in a view and maybe you have a refresh schedule, that's going to be your first option if you have that, and then persist it into a table.
Thank you.
Yeah, welcome. All right.
This came up, I think, last presentation, the previous one, the choice of whether to continue to use hashed keys in the information mart is also has an effect on your downstream BI tool, right? Because your BI tool, may be affected by the use of hash keys. Like Power BI, I haven't done this, but what I've heard is that the size of your model, it doesn't slow down the performance because Power BI basically just replaces your hash keys with an integer join, but it keeps that in your model. So the size of your model in RAM becomes larger. And so like that, what BI tool and how it performs downstream would have an effect on the choices that you make upstream and how you're going to do keys and in your information marts and whether hash keys are appropriate there.
I would imagine you'll have a surrogate key.
I think the proposal, if you're using views on top of a hashed key data warehouse, there would be no place to produce an integer surrogate key. It would still be the hash key.
That's correct, because the one of the main advantages of the hash key is for loading data fast, right? If you have a surrogate key and you got data coming in into your fact table, right? You have to do a join back to your dimension to go get that surrogate key to write to your fact table. That join on data coming in is what slows down the ingestion process. So that's where the benefits of the hash key, it's a trade-off, right? I mean, you're going to be able to bring this data in fast, but you know, if you need the true performance of a, you know, of an enterprise star schema with integer-based surrogate keys, by all means, you know, that there's nothing saying that the use of Data Vault out, you know, kind of rewrites the whole best practices of a star schema. That lookup can still be performed, and you can still use surrogate keys, no question.
Right, and different databases, including BI semantic layer databases, have different ways of handling hashed keys versus integer keys. So understanding the way that your BI tool in particular will handle that and probably testing it would be a good thing to do before you choose this as your path.
All right.
All right.
Yeah, thanks everyone for joining here and online. I guess that we're going to